If you are preparing for a Gen AI or LLM interview, you will almost definitely get questions about prompt engineering and chatbots. In this video, we will break down 6 of the most important questions: chain of thought prompting, self consistency prompting, how to design prompts for code, what prompt templates are, chatbot versus LLM, how to build a chatbot with the OpenAI API. We will go through each concept step by step with practical examples and visuals that you can remember and reuse in interviews. Let's start with one of the most powerful reasoning techniques: chain of thought prompting. Chain of thought prompting, or COT, is a prompt engineering technique where we ask the model to show its reasoning step by step instead of just giving the final answer. Most models can produce an answer directly, but they sometimes make mistakes on multi-step problem like math, logic, or complex reasoning. Chain of thought prompting solve this by forcing the model to walk through intermediate steps. The idea is simple. First, understand the problem, then we break it into small sub-steps. We reason through each sub-step. Finally, we combine the result to get the answer. For example, instead of asking what's 27 multiply 43 and expecting only a number, you might write explain your reasoning step by step, then give the final answer. What is 27 multiplied by 43? Now the model will breaks the multiplication into parts, show intermediate calculations, and then produce the final result. In practice, chain of thought prompting can be triggered with simple cues like let's think step by step, so your reasoning, or a few short examples where you demonstrate work solutions. This improves transparency, reliability, and performance on a complex reasoning task without retraining the model. Chain of thought prompting is all about showing the reasoning. Our next technique, self consistency prompting, is about using multiple reasoning paths to choose the best answer. Self consistency prompting builds on a chain of thought but adds a clever twist. Instead of generating one reasoning chain and trusting it, we generate many reasoning chains and then pick the most consistent final answer. Here is the core idea. Ask the model to think step by step several times using temperature or sampling so it explore different reasoning paths. Each run produce a chain of thought and a final answer. We then look at all the answers and choose the one that appears most frequently, typically via majority vote. This works because even if some reasoning parts are noisy or wrong, the most common answer across multiple attempts often turns out to be correct. For example, if we ask a tricky math word problem, run one reasoning answer 27, run two reasons answer 27, run three reasoning and answer 31, run for reasoning and answer 27. The model might pick 27 as the final answer because it appears most often. So, chain of thought equal to so one reasoning path, self consistency equal to generate several paths and pick the most consistent answer. This technique can dramatically improve reliability on complex reasoning tasks, especially when combined with good prompts and temperature settings. Now that we have talked about reasoning prompts, let's move to a more practical topic: how to design prompts for a code. Designing a prompt for code is one of the most practical skills in Gen AI interviews. Good coding prompts are clear about the task, specific about the constraints, and structured to get a reliable, readable code. Here is a simple framework you can mention in interviews. State the role and language clearly. You are an expert Python developer. Describe the task precisely. What should the code do? Inputs and outputs, edge cases, performance constraints. Specify a format requirements. Return only code, no explanations. Include a comments explaining each major steps. Provide a functional level docstrings. Fourth, add examples or a test. Provide simple inputs and expected outputs. Ask the model to include simple unit tests where appropriate. Include safety and style rules. Avoid external libraries unless explicitly allowed. Follows PEP8 style guidelines. Handle errors gracefully. For example, you are an expert Python developer. Write a function, some even number num, that takes a list of integers and returns the sum of all even numbers. Include docstring comments and at least two PyTest style unit tests. This kind of prompt makes it much easier for the model to produce a high quality usable codes. Once our prompts are well designed, the next step is to make them reusable. That's where prompt templates come in. Prompts templates are a predefined structure for prompts that you can reuse and fill with different values. Instead of writing a brand new prompts every time, you create a general pattern and then insert specific details when you need. Template might look like this. You are a helpful assistant, task, task description, input text, constraints, output format. Here, task description, input text, and constraints are variables you swap out depending on the situation. Prompt templates helps you keeps prompts consistent, reduce mistakes, scale across many tasks, and integrate a prompt into production systems programmatically. For example, a customer support templates, a code generation template, summarization template, or data extraction templates. Prompt templates are structured input formats that define role, tasks, and fields in a reusable way. They are essential when you build a system that call LLMs repeatedly with different inputs. Next, let's clarify a very common confusions. What's the difference between a chatbot and an LLM? People often use chatbot and LLM interchangeably, but they are not the same things. An LLM is the underlying model like GPT-4, Gemini, or Claude. It's trained on massive text datasets to predict the next token and generate languages. A chatbot is an application built on top of one or more LLMs. It usually includes a user interface, chat window, app, website, conversation logic, system prompts and policies, memory or context management, integration with tools, APIs, and databases, and sometimes multi-agent orchestrations. So the LLM is the engine. The chatbot is the car built around the engine. A simple LLM API call might just be given this prompt, return a completion. A chatbot, on the other hand, might maintain conversation history, inject system message like you are a customer support assistant, call tools to look up account information, and format a response in a very specific way for users. An LLM is the base model that generates text. A chatbot is a full system that wraps the model with UI, memory, tools, and business logics. Now that we have distinguished chatbots from LLMs, let's briefly outline how to build a chatbot using the OpenAI APIs. Finally, let's walk through a high-level process for building a chatbot with the OpenAI API. You can describe this in a interview as a five-step pipeline. Set up API access. Get your API key from OpenAI or Azure OpenAI etc. Install the client library, for example, Python or JavaScript. Store keys securely in environment variables. Define the system prompt and role. Decide what kind of chatbot you are building, customer support, coding assistant, tutor, etc. Write a clear system message like you are a helpful support chatbot for company X. Always ask clarifying questions and be concise. Handle user messages and context. Collect user input from the UI. Maintain a conversation history, previous user messages, and assistant responses. Send messages to the API in a structured format. Role system user assistant. Call the OpenAI chat API. Use the API to send the message list and receive a response. Configure parameters such as temperature, max tokens, and tools if needed. Integrate tools, memory, and UI. Add tool calls, example database lookup, search, CRM APIs using function calling. Store relevant data in a memory layer. If you need a persistent personalization, display response to the user in the chat interface and repeat the loops as the conversation continues. In code, the flow is user message to build a messages list, call if OpenAI, receive response, render, optionally call tools and continue. At an interview level, it's enough to show you understand API setup, system prompts, conversation context, tool integration, and safety mode configurations. Let's quickly recap what we covered. Chain of thought prompting, guiding the model to think step by step. Self consistency prompting, sampling multiple reasoning parts and choosing the most consistent answer. Designing prompt for code, being explicit about role, task, format, and taste. Prompt templates, reusable prompt structured with variables. Chatbot versus LLMs. The LLM is the engine, the chatbot is the full application. Building a chatbot with the OpenAI API from system prompt to tools and UI. These concepts come up constantly in GenAI interviews and real world projects. If you found this helpful, hit like, subscribe to the channel and share this video with everyone learning from engineering or building chatbots. Thanks for watching and I will see you in the next video.